So imagine buying a house, right? Building your whole life inside it, and then, like, 5 years later, bank calls.
Never call you want to get.
Exactly.
Huh.
And they tell you that you now have to start paying this massive monthly rent just for the concrete foundation.
Which is just an insane position to be in.
Right. And if you don't pay up, the entire house collapses. That is exactly the kind of shockwave hitting enterprise IT right now. Welcome, everyone, to Vpod.ai. I'm your host, Mike, and sitting across from me today is our expert, Susan.
Thanks for having me. It is a wild time in the tech world right now, that is for sure.
Oh, absolutely. But real quick before we begin, this podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, public and private cloud. Check out stonefly.com. Okay, so going back to that concrete foundation.
Right, the IT infrastructure.
When you build an IT infrastructure, there is this expectation of permanence. I mean, the ultimate goal is for it to be totally invisible.
Yeah, working quietly so you can actually run your business.
But right now, everyone is suddenly looking for ways to just jackhammer out their established foundation and pour something totally new. Why the sudden panic?
It really all traces back to a single massive Catalyst Broadcom's acquisition of VMware.
Ah, right.
For over a decade, VMware was the default, undisputed king of virtualization. Historically, organizations purchased perpetual licenses.
Meaning you just bought it once.
Exactly. You bought the software, it was yours forever, and you just paid a relatively small annual maintenance fee for, like, patches and support.
Makes sense.
But almost immediately after the acquisition, Broadcom eliminated those perpetual licenses entirely. They shifted the whole ecosystem to a subscription-only model.
And from looking at the fallout, they didn't just change how you pay. They completely, gutted the menu of what you could even buy.
Oh, absolutely. They took a massive catalog of, I think it was 168 different software SKUs.
That is a lot of options.
Right, individual products you could pick and choose from, and they consolidated them down to essentially 2 bundled packages.
Which sounds nice in theory, like a simplification.
In theory, sure. But in practice, organizations are seeing their renewal quotes come back with price hikes of 500 to 600%.
That is just wild.
Yeah, they are basically being forced to buy colossal software bundles full of stuff they do not even use just to keep their core virtualization running.
It is essentially like going to your favorite local diner, right? Where you have bought a simple $3 cup of coffee every morning for a decade.
Mm-hmm.
But the diner gets a new owner, and suddenly you cannot just buy coffee. You are required to buy a $50 all-you-can-eat breakfast buffet ticket.
Even if you don't want the food.
Exactly. You don't want the eggs, you don't want the pancakes, but if you want your coffee, you are paying $50.
That analogy hits the nail on the head, honestly. And while a massive tech giant might be able to swallow that $50 ticket, it is totally devastating for organizations with strict, non-negotiable budgets.
Like hospitals, right? I heard the healthcare sector is feeling this squeeze more than almost anyone.
Oh, without a doubt. Hospitals operate on razor-thin margins. Their IT environments aren't just complex, they are keeping people alive.
Right. You were talking about electronic health records, advanced imaging archives, laboratory systems.
Things that absolutely cannot go offline.
You can't exactly pause the emergency room to swap out the servers.
Yeah.
So what do? Do they just pay the ransom?
In the short term, many of them are. IT directors at these hospitals are holding their noses and signing these massive new contracts just to buy themselves a year or two.
Just to figure out a plan.
Exactly. Because ripping out a legacy virtual environment and moving it to a new platform is equivalent in scale, cost, and risk to physically packing up a data center and moving it to another state.
Wow.
But the clock is ticking, and the desperate search for a lifeboat is definitely on.
Which brings us to the leading alternative that is suddenly everywhere. Proxmox Virtual Environment, or Proxmox VE. For anyone who has only ever lived in the VMware bubble, what makes Proxmox tick?
To really understand the appeal, we have to look at the architecture. VMware's core technology, ESXi, is a purpose-built, highly curated, bare metal hypervisor.
It is a closed box designed to do one thing perfectly.
Precisely. So Proxmox takes a wildly different approach. It is an open source platform built directly on top of just a standard Debian Linux operating system.
Okay.
And it relies on 2 main technologies. So you have KVM for your full virtualization and then LXC for containers.
Let's pause on KVM and LXC for a second because, those acronyms get thrown around a ton.
Mm.
KVM is kernel-based virtual machine, right? How is that actually creating the virtual servers?
KVM fundamentally turns the Linux kernel itself into a hypervisor. It intercepts all the software calls and routes them directly to the physical hardware.
Tricking the system,
And
essentially.
it tricks the guest operating system, like Windows or another Linux instance, into thinking it has its own dedicated physical motherboard, memory, and processor. It is really robust hardware-assisted virtualization.
And LXC, the containers, that's a totally different beast entirely, right?
Very different. LXC stands for Linux containers. Instead of faking a whole hardware environment like KVM does, LXC just sections off a little sandbox inside the host's existing Linux kernel.
So it shares the brain.
Right. And because it doesn't have to boot up a separate kernel, it is incredibly lightweight. You can run hundreds of LXC containers on a server that might only be able to handle like a few dozen full KVM virtual machines.
It also seems like Proxmox takes a sort of batteries included philosophy.
Oh, definitely.
Instead of buying a base product and then paying extra for backup module or management console, it's all just in the box.
Out of the box, you get the web interface, full API access, and native integration with Proxmox Backup Server, which handles enterprise-grade, deduplicated backups.
That is huge.
It is. You also get built-in support for advanced storage architectures right from day one.
Okay, I have to play devil's advocate here for a minute. If Proxmox provides all of this out of the box, and the core software is open source and potentially free, why isn't every Fortune 500 company switching overnight?
That is the big question.
Right. What is the catch for you as an IT decision maker? Because in enterprise tech, there's always a catch.
The catch is the ecosystem and the safety net. VMware has spent 20 years building turnkey certified integrations.
Meaning everything just works together.
Exactly. If you buy a $2 million storage array from a major vendor, they guarantee it plugs into VMware seamlessly. If it breaks, you call a single support number. Proxmox simply does not have that same level of ubiquitous certified vendor integration.
So you are basically trading expensive software subscriptions for a massive reliance on your own team's brainpower.
Precisely. Because Proxmox runs on a general-purpose Debian base, your team needs inherent Linux engineering skills.
You can't just click next, finish.
No, you really can't. You have to manually size your hardware perfectly, and you have to deeply understand how to manage kernel updates without breaking your storage drivers. The operational burden definitely shifts back onto your staff.
Let's talk about that hardware sizing, actually, because you can't just install this on any server sitting in a closet. The blueprint is surprisingly strict.
Very strict.
I was looking at the hardware requirements, and it specifically demands ECC memory for production environments. Why is standard RAM an absolute deal breaker if you are trying to cut costs?
It comes down to a terrifying concept called silent data corruption.
Doesn't sound bad.
It is. Standard RAM is susceptible to environmental factors, like a stray cosmic ray or random electrical interference can occasionally flip a tiny memory bit from a 0 to a 1.
And standard RAM has no idea this even happened.
None at all. Now, if you are using advanced software-defined storage on Proxmox and corrupted data hits your RAM, the system will permanently write that corrupted data to your hard drives.
Wow. And if you are running, say, a hospital database, a flipped bit could literally change a patient's medication dosage or completely corrupt a financial ledger.
Exactly. Error-correcting code, or ECC memory, actively detects and fixes those bit flips in real time before they ever reach the drives.
So it is non-negotiable.
Completely. Skipping ECC RAM in a production environment is quite literally playing Russian roulette with your company's data.
Sticking with memory, there is a massive overhead requirement that caught my eye. If you use ZFS, one of those advanced file systems you mentioned, you have to allocate roughly 1 gigabyte of RAM for every terabyte of storage capacity.
Yeah, it is heavy.
Why is Proxmox so memory hungry just to manage hard drives?
Because ZFS is doing all the heavy lifting that historically used to be done by an expensive physical hardware card.
That's interesting.
Yeah, it uses something called the ARC, or Adaptive Replacement Cache. It intelligently takes your most frequently accessed data and the directory maps of your drives and keeps them in your ultra-fast RAM.
Sounds like a massive shortcut.
Right. This way, when a user requests a file, the system doesn't have to sit there and wait for the physical hard drives to spin and find it. But to map hundreds of terabytes of storage efficiently, that RRC cache needs a massive amount of memory.
I also noticed a fascinating quirk about ZFS. It absolutely refuses to work with hardware RAID controllers.
It really does. ZFS is very stubborn about that.
It feels like ZFS is a massive micromanager. Like, It sees the RAID controller as middle management and just refuses to deal with it, demanding to speak directly to the hard drives on the factory floor.
That is a brilliant way to picture it, actually. ZFS relies on knowing the exact raw state of every single physical disk to monitor for failing sectors and to heal data.
If a RAID controller is sitting in the middle, lying to ZFS and saying, everything is fine, I am just one big healthy drive.
Then ZFS is flying blind. It cannot do its job. It will eventually crash or completely corrupt your data. It absolutely must have raw disk access.
Now, ZFS is great if your storage is local to one physical server. But what if you want a cluster? What if you want to mirror VMware's vSAN, where the storage is shared across multiple machines?
For shared storage, you use Ceph. It is a distributed block storage system.
And you need, a minimum of 3 physical servers to run that?
Yep, at least 3. It basically takes all the hard drives across those 3 servers and pulls them together over the network into one massive shared storage bucket.
And having that shared bucket is what allows for live migration, right?
Mm-hmm.
I mean, explain the magic of how that actually works, because it sounds crazy.
It really is one of the most incredible feats in virtualization. So, say server A needs physical maintenance.
Like a RAM upgrade or something.
Right. Because the storage is shared on Ceph, the actual hard drive files do not need to move at all.
Oh, I see.
Proxmox just takes the active running memory state of the virtual machine on server A, synchronizes it over the network to server B in literal milliseconds, and then cuts over the processing.
And the virtual machine never actually turns off?
Never. The user who is streaming a video or pulling a database query never even notices their server just physically jumped across the room.
That is just wild. But that highlights a pretty huge pitfall, right? Moving that much data in milliseconds means your networking plumbing has to be absolutely flawless.
It is the #1 reason these migrations fail, honestly. Proxmox requires strict physical separation of network traffic.
Right.
And the most critical piece of that is the CoreSync network. This is essentially the private channel the servers use to talk to each other and maintain the cluster state.
They're constantly checking in with each other.
Exactly. They send heartbeat signals to agree on who is alive and who is hosting which virtual machines.
And the requirement for CoreSync is a dedicated 1 gigabit link with sub-5 millisecond latency. So what happens if that network blips? Do the servers just pause?
No, they get deeply paranoid.
Uh-oh.
Yeah, if the heartbeat drops, the cluster enters what we call a split brain scenario. The servers assume the other machines have straight up died.
So they panic.
Basically, to prevent 2 servers from accidentally trying to write to the same hard drive file at the same time, which would instantly destroy the data, they initiate a process called fencing.
Fencing, what does that do?
A node will literally restart itself or forcefully kill its virtual machines to protect the storage.
Wow. So a single faulty network cable can take down your entire infrastructure.
It absolutely can. And then there is the raw speed required for moving the actual data.
Right, the math on that is eye-opening. If you are migrating a 1 terabyte virtual machine over a standard 1 gigabit network, it takes 2 to 3 hours. But over a modern 10 gigabit network, that same terabyte moves in 15 to 20 minutes.
Huge difference. And when you are migrating hundreds of machines, a small difference in network speed turns a weekend and maintenance window into a month-long nightmare.
Nobody wants that.
No. That is why your Ceph public network, the traffic between the VMs and the storage pool, needs 10 gigabits minimum. If you are using lightning-fast NVMe flash drives, you truly need 25 gigabit networks or higher.
Otherwise, your network cables become a massive traffic jam, completely bottlenecking your expensive hard drives.
Exactly.
Let's shift to the actual mechanics. Assuming you have the network isolated, the ECC RAM installed, and the storage mapped.
All the fun stuff.
Right. How do you actually get the data out of VMware and into Proxmox without, manually rebuilding everything from scratch?
Well, the tooling has evolved beautifully over the last bit. In Proxmox version 8.2 and newer, there's this integrated import wizard.
Oh, nice. Yeah, you literally just point your Proxmox server at your old VMware environment, enter your credentials, and the API just takes over.
It is that simple.
Pretty much. It pulls the old VMDK disk files over the network and automatically translates them into the native POW2 formats that Proxmox uses.
That eliminates the brutal command line conversions we had to do even a few years ago. But where do you physically put this new Proxmox environment? It seems like bare metal hosting is becoming the massive trend here.
It is entirely changing the financial equation. Traditionally, you either had to buy physical servers and cool them in your own building, or rent shared space in the public cloud where you don't actually control the hypervisor.
Right.
Bare metal providers, like Open Metal, offer a middle ground. You lease dedicated physical server hardware in their data centers.
And you get full root access to install Proxmox directly on the metal.
So you completely dodge the massive capital expense of buying $500,000 in server hardware upfront, but you retain the absolute control of an on-premises setup. The return on investment we are looking at is wild.
It is staggering.
For a medium-sized company migrating a 3-node cluster, dropping the new Broadcom licensing can save $20,000 to $40,000 annually.
And that operational savings pays for the lease on brand new, vastly superior bare metal hardware almost immediately. You stop feeding the licensing machine and start investing in raw performance.
But to be fair, Proxmox is not the only lifeboat in the harbor. We are seeing organizations take a few different paths based on what they already own or what their staff knows.
Absolutely. For organizations that want that highly polished single pane of glass experience similar to VMware, Nutanix is a phenomenal alternative.
Right, but it comes at a cost.
It does. It is a premium hyper-converged infrastructure. It does the storage, networking, and virtualization brilliantly, but you are still paying a premium enterprise price tag.
Then there's Microsoft Hyper-V, which I think is kind of the dark horse here.
Oh, for sure.
If an organization is already heavily invested in Microsoft, they might already have the golden ticket. If you pay for Windows Server Data Center Edition, it includes the right to run an unlimited number of Windows virtual machines on that host. You literally just turn on the Hyper-V role.
The hypervisor is essentially free because it's already on your receipt.
Yeah.
It is a massive draw for all Windows shops.
Makes total sense.
We are also seeing a shift in desktop virtualization. Companies moving away from VMware Horizon are finding a natural landing spot in Azure Virtual Desktops.
What about Citrix?
Well, we should mention Citrix is technically an option for virtual desktops, but they recently instituted their own massive price hikes, so the cost-saving angle there has completely vanished.
Ouch. This wealth of options is leading to a fascinating strategy, though. It doesn't have to be an all-or-nothing exodus, does it?
Not at all. The smartest enterprise architects are adopting a strategy of coexistence.
The hybrid approach.
Exactly. A hospital might keep its heavily audited Tier 1 electronic health records firmly on VMware. They pay the new premium because they absolutely require that certified vendor safety net for the core systems.
But for everything else.
They migrate their research and development, their IT labs, and their edge computing environments over to Proxmox or Hyper-V.
That raises a huge question about the human element, though. Are we looking at a permanent hybrid reality where IT professionals have to be completely bilingual?
I think so, yeah.
Like the days of someone stamping VMware administrator on their resume and calling it a career seem to be over. You now have to know how to write an Ansible playbook for a Linux-based Proxmox cluster in the morning, and then troubleshoot a PowerShell script for a Windows Hyper-V server in the afternoon.
That is the new reality. Adaptability is the ultimate currency for engineers right now, the operators who truly understand the underlying physics.
How the engine actually works.
Right. How storage packets move, how CPU scheduling works, how latency affects databases, they will thrive. The logo on the dashboard won't matter to them. The power is shifting away from vendor certifications and back toward fundamental engineering skills.
It makes you wonder where this all leads. Like if open source hypervisors can comfortably run enterprise workloads.
And bare metal hardware can be leased on demand, like a utility.
Exactly. Are we watching the concept of the massive, monolithic software vendor lock-in model disappear?
It is a strong possibility. We might be entering an era where IT infrastructure is entirely open and modular.
Which is a huge shift. Definitely something to mull over. Also, before we wrap up, be sure to check out the 100 TB immutable and air-gapped SSO NAS for $8,995 by Stonefly.
Some serious storage there.
For sure. Thank you all so much for joining us for this conversation. Look at the foundation your organization is standing on today. Is it solid, or is it time to bring out the jackhammer?
Great question.
Until next time, keep questioning what you're building on.